The Sun is the central star of our solar system and is the most critical source of energy for life on Earth. It is a nearly perfect sphere of hot plasma, with internal convective motion that generates a magnetic field through a dynamo process. The Sun's diameter is about 1.39 million kilometers, 864,000 miles, making it 109 times wider than Earth. Its mass accounts for approximately 99.86% of the total mass in the solar system, with the remaining 0.14% distributed among planets, moons, asteroids, and other celestial bodies. The Sun's immense gravitational pull keeps the solar system intact, dictating the orbits of all planets and smaller objects. The Sun is composed primarily of hydrogen, about 74%, and helium, about 24%, with trace amounts of heavier elements such as oxygen, carbon, and iron. At its core, nuclear fusion occurs, where hydrogen atoms fuse to form helium, releasing enormous amounts of energy in the form of light and heat. This process, known as nuclear fusion, generates temperatures of about 15 million degrees Celsius, 27 million degrees Fahrenheit. The energy produced in the core takes thousands to millions of years to travel to the Sun's surface, or photosphere, before being emitted as sunlight. This sunlight travels approximately 8 minutes and 20 seconds to reach Earth, providing the energy necessary for photosynthesis and sustaining life. The Sun's structure consists of several layers: the core, radiative zone, convective zone, photosphere, chromosphere, and corona. The photosphere is the visible surface of the Sun, where sunlight is emitted. Above the photosphere lies the chromosphere, a layer of glowing gases that can be seen during solar eclipses as a reddish halo. The outermost layer, the corona, is a faint, wispy atmosphere of plasma that extends millions of kilometers into space. The corona is significantly hotter than the Sun's surface, with temperatures reaching up to 1 to 3 million degrees Celsius, 1.8 to 5.4 million degrees Fahrenheit, a phenomenon that scientists are still working to fully understand. The Sun exhibits dynamic and complex activity, including sunspots, solar flares, and coronal mass ejections, CMEs. Sunspots are temporary, dark regions on the photosphere caused by intense magnetic activity, and they often appear in pairs or groups. Solar flares are sudden bursts of energy and radiation caused by the release of magnetic energy, while CMEs are massive eruptions of plasma and magnetic fields from the Sun's corona. These phenomena can have significant effects on space weather, potentially disrupting satellite communications, power grids, and even posing risks to astronauts in space. The Sun's magnetic field plays a crucial role in its activity. It undergoes an 11-year solar cycle, during which the number of sunspots and solar activity fluctuates. At the solar maximum, the Sun experiences heightened activity, with more sunspots, flares, and CMEs. At the solar minimum, activity decreases, and sunspots become rare. This cycle is driven by the Sun's internal magnetic dynamo, which is influenced by the differential rotation of its layers. Understanding the solar cycle is essential for predicting space, weather, and its impact on Earth. The Sun is approximately 4.6 billion years old and is considered a middle-aged star. It formed from a giant molecular cloud of gas and dust, collapsing under its own gravity. Over its lifetime, the Sun has gradually increased in brightness and will continue to do so. In about 5 billion years, it will exhaust its hydrogen fuel and enter the red giant phase, expanding to engulf the inner planets, including Earth. Eventually, it will shed its outer layers, leaving behind a dense core known as a white dwarf, which will slowly cool over billions of years. The Sun has been a subject of fascination and study for centuries. Ancient civilizations revered it as a deity, and its movements were used to create calendars and track time. Modern science has revealed the Sun's true nature as a star, and ongoing research continues to uncover its mysteries. Space missions like NASA's Parker Solar Probe and ESA's Solar Orbiter are providing unprecedented insights into the Sun's atmosphere, magnetic field, and solar wind. Understanding the Sun is not only crucial for advancing astrophysics, but also for protecting our technology-dependent society from the effects of solar activity. The Sun remains a symbol of life, energy, and the dynamic forces that shape our universe.